Okay, so for this question, this is from quiz 1 time practice paper 1. We're supposed to express this in the form of x plus p squared plus q. Okay, so I believe okay, let me just work it out. So this is x squared. I will need the plus 1.5 squared. So since I identify that the coefficient of x squared is positive 1, so with negative 3x, what I should be adding is 1.5 squared. Okay, and from here, then I continue to leave my 3 outside. The 3 is part of the original equation. So those original ones are in red. Then I'll subtract 1.5 squared. Subtracting 1.5 squared is 3 minus 1.5 squared. That should give me 0.75. So this is my part 1, which will be in total of x minus 1.5 squared plus 0.75. Okay, so this is my part 1. Okay, so with that, while solving part 2, I think you should realize that there's no solution. Okay, but from part 2 and part 3, what does it understand is because if you look at the graph, right, the graph is going to be like this. Okay, it's not going to have any x-intercept. Okay, it's not going to have any x-intercept. So because the turning point will be 1.5, 0.75. You notice that there is no intersection with the x-axis. Okay, if there's no intersection x-axis, it means that, you know, if I try to, because this is where y is equals to 0, so there is no x-intercept. There are no x-intercepts, meaning y equals to negative x squared minus 3x plus 3 has no x-intercepts. So if this equation have no x-intercepts, what does it mean is that if I try to sub, that means if I try to sub y as 0, if I sub y as 0, meaning 0 equals to negative x squared minus 3x plus 3, because that's what we do, right? When we find the x-intercept, we will replace y as 0. This, because of the fact that there are no x-intercept, this is not going to have any solution. Oh, sorry, shouldn't be have, it has no solution. All right, it has no solution. So because it has no solution, when in such a case there is no real roots, right, we can conclude that the discriminant is less than 0. Okay, without even calculating. If you were to choose to calculate, you can see that from here, my A is -1. From here, my B is -3. From here, my C is just 3. So that is my not negative x squared. Oh, sorry, Darren. Oh, yes, my bad. Thank you so much. Thank you, Hamza. Okay, so from here, right, A is +1. I'm doing it without looking at the answer. So I stay unbiased. Okay, so from here, discriminant is B squared minus 4AC, which gives us 9 minus 4 times 3, which is 12. That's -3. And you can see that it is less than 0. So far, okay? Can I? Okay, if there are people admitting, just help me to admit them as much as possible. Okay, and when you're here, do all your okay. Okay, this is to give us the due connection with each other. Okay, so with that, Maxine, are you there? Maxine,
yeah.
Okay, do I answer your, so far okay, ma? Do I answer your question?
Yeah.
Despite, huh? Okay, good. So I'll just pause here for a while, and after that, I'll go to the next one. Okay. So next one is, Maxine, your question 2, where is it from? I just want to check. The second photo you sent me. Let me take away my background. My background, not very nice. Yeah. Just give me a while. Okay, I cannot minimize Zoom because I'm recording. Okay, never mind. Maxine, is it okay you tell me where's this question from? Question 2.
It's from the quiz 1 time practice paper 1.
Quiz 1 time practice paper 1. Thank you. Okay, so this is from, again, quiz 1, not just quiz 1 time practice, but quiz 1 time practice paper 1. Okay, so for this question, what we want to do is we want to solve for x. And before we solve for x, this part actually is from JH1. It requires us to, simplify this equation. And this is under topic 1, part 4, where we have a fractional equation that can be reduced to a quadratic equation. Our outcome is to try to reduce it in the form of, finally, we're going to have something like ax squared plus c equals to 0. Right? We want to reduce this. We want to reduce this to ax squared plus bx plus c equals to 0. And finally, from there, then we can solve. Okay, so how do we go about doing that? Definitely, it involves us simplifying this fraction, the left-hand side, into finally one singular fraction. And it's easy for us to cross-multiply. So from here, what we need to do in this aspect, when we look at this fraction, we definitely need to look for common denominators to simplify. So on the right-hand side, 5 over 2 minus x, I'm just going to do my best to factorize my denominator so that I want to merge these two fractions into one. Okay, I want to merge these two fractions into one. Okay, I take out a 4. This is 4x squared minus 4. So after factorizing, this is what I have. Further factorize again. This is 4 bracket x minus 2, x plus 2. And what I'm doing here is I first take out a common factor 4, followed by using the algebraic identity. A squared minus b squared is a minus b, a plus b. Okay? And then I observe, oh, there's a 2 minus x and there's x minus 2. So what can I do is I can, I look at these two, right? It seems like they are like in the same term, but they are in reverse order. All right, if I want to make them the same, probably I can do that. Let me just write this as negative of 2 minus x. So far, okay? Let's see, so far, okay? Can I? Okay. Then with that, negative and negative, that gives me a positive. Okay, so I have 5 over 2 minus x added to 8x plus 3 over 4 of 2 minus x, x plus 2. Okay, and while I look at this fraction too, I can combine, right? I'm just short of a few common terms now. So I'm going to do what I do here. So I multiply by x plus 2 over x plus 2. I see a 4 here. I multiply by 4, multiply by 4. Okay, those in red are what I just added in, just to make sure that the denominator is the same. Equals to 2, right? Okay, so I put equals to 2, equals to 2. This is equals to 2. And from here, okay, 4 times 5, 20x. That is 20x, okay? 4 times 5 times 2, that is 40. Added to 8x plus 3. Okay, I'm just going to merge my entire numerator and denominator together. Because I have now the same denominator, I can add my fractions, okay? So before we even talk about the two, what I'm doing is I'm simplifying the fractions first, okay, which is your first priority, to make it as simple as possible before you can start to solve. With the 20x and the 8x, okay, I look for common terms to merge together. Now, I'm not going to be putting them together so soon. So this will give me a 28x. So I write down 28x. I look at 40 and 43. That's going to give me plus 43. Okay, and what I want to show you is I want to bring this 2 minus x over to the other side. Okay, I'm going to do like a cross multiplication. I'm multiplying by the denominator over. All right. So this is equals to 2 multiplied by 4 multiplied by 2 minus x multiplied by x plus 2. Okay, so I want you to see how I brought the entire term over to the right hand side. Okay, this is just very humble cross multiplication. Okay, remember that our endpoint, right, is to get our endpoint end of the day is to get ax squared plus bx plus c. This is our end goal. Okay, we want to solve this. I want to solve this. I want to achieve this so that I can solve. So I'm almost there, and I have to expand this for sure. While expanding this, the journey definitely is also not easy. 2 minus x, x plus 2. I can see it this way. I can see it as 2 minus x, 2 plus x. And I think of a minus b, a plus b. Okay, which is eventually, 8 is here, 8 of a squared minus b squared equals to 28x plus 43. Okay, open up everything. 8 times 4 is 32. 8 times minus x squared is negative 8x squared equals to 28x plus 43. Okay, then after that, let me just put everything to the right hand side. Ax squared minus 28. X will just be by itself. It's still 28x. There's nobody to mingle with. Now, if I take 43 and I bring it over, this will be a minus 32. Yeah, sorry, I bring over. So that will be finally 11. Okay, and with this, you can, the fact that they say giving the answer correct to 2 decimal place, right? It will tell you that it's not factorizable. Okay, it's definitely quadratic formula or completing the square. All right, so here you can see A is equals to 8, B is equals to 28, C is equals to 11, using the quadratic formula X equals to negative B, plus minus square root B squared minus 4AC over 2A, and after that, my answer is done. So I'm just going to go to my calculator here. I wonder if it works. Sorry. 8, 28, 11. So at this part, I'm just going to go to my calculator. So I'm going to press 5. I go to polynomial. The degree is 2, right? Because it's quadratic. What's the equation again? Sorry. 8, 28. 8, 28, 11. Okay, so I'm going to press 8, 28. Oh, shucks. 8, 28, 11. Okay. My first answer will be negative 0.409681. Okay, of course, this is the part I'm not going to show the examiner. All right, it's just for me to play cheat so that I am, I am quite sure that I won't get a careless picture. Okay, so usually, even though I use the quadratic formula, like you, I'm a student, right? I like to find the safest way to get my answers. So I'll write down negative 0.4096 or negative 3.049. To 3 significant figures, that will be negative 0.451, 3 or negative 3.05, 3. And this is my final answer here. So far, okay? Can all? Okay, so I'll just pause at this page for a while. Again, children, this is from quiz 1, time practice, paper 1, question 2. Question 2, and I think we have done this before in class. It's a taken from another. Can I? Okay. So I'll go to the next one. Okay, so I believe the other questions should be from here. Okay. Can I just check 1B? Do I need to go through, or is it not the Maxine? This is 1B is from the in the WhatsApp group 1B. You are not referring to this one, right? Or don't need? Did anyone ask for this 1B? Oh, okay, can 1B, yeah. Okay, thank you. If you can just unmute because yeah, you see my camera looks like that. I can't really see anyone. I can't see everybody. I can't see everybody. So because my camera looks like this, so I can't see. If you can just unmute, just shout me. Okay, then I know can already. Okay. So let me go through 1B. again, we are solving a quadratic equation. We do not really want the right-hand side to be non-zero. The only case where if I want it to be non-zero is unless I'm going to be square rooting both sides, unless I square root both sides. So personally, I always prefer, like in all my quadratic equations, right? What I like to do is to form it in the form of ax squared plus bx plus c equals to 0, which is why you will see that Ling Xuan, I'm doing it here. Okay, so this guy, it looks very tempting. Like it's so nicely put there, right? It seems like it's as though we're going to use it straight away, but unfortunately, no, we're not doing it. We have to expand it. So even though the brackets are so perfectly put together, I have to break them apart. Huh? So x to 2x, that gives me 2x squared. X to negative 9, that gives me a negative 9x. 2 to 4x, 2 to 2x, that gives me a 4x. 2 to negative 9, that gives me a negative 18. At the same time, I'm going to bring my 24 over. So I have a negative 24 equals to 0. So far, so good. Okay, huh? Can, okay. And from here, what do I do next? Of course, I will combine. Can we make one of the brackets 24 and then solve? Unfortunately, no, you cannot. You cannot. Okay, you have to follow the zero product rule. Okay, Hamza, are you there? Where are you? Sorry, I cannot find. Okay, so Hamza, just let me finish it. Then after I'll explain to you why your question has a different perspective. Okay, so if I look at this, right, so maybe again I want to merge negative 9 and 4x. That will give me negative 5x. 2x squared has nobody to mingle with, so he's very sad, he's by himself. Negative 18, negative 24. That gives us a negative 42. Okay. And from here, I can think about, I can think about factorization, but it seems like there's nothing. So again, I'm just going to go back to my calculator. I'm going to press 2, negative 5, negative 42. Okay. But of course, that's not what I'm going to show. I see that I got answer 6 and negative 702. So on the side, when you don't show the teacher, right, you got x equals to 6 or x equals to negative 702. So this is actually the final answer, but this is not what I'm going to write down. What I'm going to write down is I'm going to backtrack. This means that x minus 6 equals to 0. Or here, if I backtrack, 2x equals to negative 7, aka the factor should look like this, 2x plus 7 equals to 0, aka the factor should look like this, x minus 6. So this is what I actually do. So Ling Xuan, if you saw what I did, right? Actually, I'm just using the calculator to play cheat. Okay, if you are clever enough, right? You can actually use the calculator to backtrack. Okay. Okay, but what you must not do is you cannot write this. From here, you got the calculator, right? Then you go and write x minus 6, x plus 7 over 2. The moment you do this, right, your lobang picture ID, so people will know that you are playing cheat because you are not considering the coefficient of x squared. If your answer is a fraction, it means that there is a coefficient of x involved. Okay? Can help? So with that, we are done with question 1b. Okay, I'm just going to pause here for about 10 seconds. Okay, if you all can, just help me show your face, full face if possible. Then unmute wherever I ask for help. Okay. Okay, so I'm going to go to the next one. Okay, so I'm going to delete this. If I'm too fast, just scream, okay? Okay, next one is question 1D, I believe. Question 1D, can I just ask who asked for this question?
Me.
Okay, can. Thank you. So for question 1D, the same principle applies. This is from topic 1, part 4. This is from topic 1, part 4, where, the topic title talks about, like resolving or, simplifying fractional equations to quadratic, to quadratic equations. So what we want to do is we want to really try to simplify this fraction as much as possible before we think about simplifying. Okay, so first, I look at these two, they seem quite granular, that it's like a simple element and there's nothing much. Oh, this looks nice. This looks like x plus 3. So I'm going to maybe think about factorizing this, and it actually gives me x plus 3 squared. So far, okay? Cannot. And let me try 2x squared. 2 plus 1, that is 10. 2 and negative 5 2. So this will probably change to x minus 2, negative 5 over 2. So it's 2x plus 5. So far, okay, huh? So when I see a fraction, I think of factorizing. So Nisha, I'm going to write down what I have here in front of you. Okay, and I'll probably cancel some common factors if I need to, okay? So I bring, maybe I can cross multiply. I can cross multiply. Then I'm just going to write those in red first, in red first on the left-hand side. Okay, I'm going to write those in red on the left-hand side. This is x minus 2, x plus 3 squared. Okay. In case you all don't know what's cross multiply, do let me know also. Okay, because some teachers I know in JH1, they might not teach cross multiply, but I do now. So the one in blue is going to be on the right-hand side. It's x plus 3 multiplied by x minus 2 multiplied by 2x plus 5. Okay. Let me try to simplify as much as possible. So I'm going to shift this to the left-hand side. Okay. So this is going to be on the left-hand side now. You see, I'm going to shift it over. This is going to stay on the left as usual. Okay, but it will be the red minus the blue equals to 0. So far, okay? Can I? Can I? Okay, hope it's okay. So before I expand everything and make a mess out of my own shirt, I look for common factors. These are things that I can take out. These are things that I can take out. So you can see that one of the things I can take out is the x minus 2, is the x plus 3 from the red. And what is left of the red? If I take out x plus 2, x minus 3, I'm left with an x plus 3 here. Okay, you notice how for the red color part, I extracted x minus 2, I extracted x plus 3, and only x plus 3 is left here. Similarly, for the blue, x plus 3 is taken out, x minus 2 is taken out. I am left with a 2x plus 5 inside. Okay, and be very, very careful. Keep your brackets all around. Okay, keep your brackets because you're moving them chunk by chunk. When you move a chunk, inside the chunk, it may be very messy. So keep a bracket around. Okay, and with that, you can see that these two are very, very nice already. They are ready to give you the zero product answers. Okay, whereas on this side, maybe you want to simplify x plus 2x. That gives you a negative x. 3 minus 5, that gives you a negative 2 equals to 0. So finally, in this solution, it means that x equals to 2, x equals to negative 3, or here, x equals to negative 2. Okay, by the zero product rule, if a times b times c equals to 0, a equals 0, or b equals 0, or c equals to 0. Make sure okay, ma? Can help. Okay. So I'll just pause at this page for a while, then you'll let you digest. Okay. Can I go through how I went to the substitution part? Hamza, is it okay? You share with me. What do you mean by the substitution part?
How you went from the x minus 2 and the x plus 3 squared, and like that equation to how it went to the bottom one.
Is it from line number 3?
Yeah, then how do you go to line number 4?
Oh, okay. So the factorization part is, if you notice, right, this is x minus 2 times x plus 3 times x plus 3. So it's I'm taking out a common factor. of x minus 2 times x plus 3. So far, okay? Can, huh? Then over here in the blue colored chunk, there's also a common factor of x plus 3 and x minus 2, which is why I can remove them also. So this red and the blue, they actually have a common factor, which is x plus 3 and x minus 2. Is that okay? Can, huh? Is that okay? Can, okay. Now that you reminded me, I also forgot to say, okay, so the part where, where's the 24 one? Oh, is it here, right? Is it here? Just now you were asking also, like, is it possible that we equate one of the brackets to 24? The answer is actually no, because we need to make the right-hand side 0. Okay, so let me give you an example, Hamza. If we take x multiplied by y to be 24, it does not necessarily mean that x equals to 24 or y equals to 24. Make sense? Because we can also have x equals to 6, y equals to 4. We can also have x equals to 2, y equals to 12. There are many possibilities. So it may not be true that 2x minus 9 equals to 24 or x plus 2 is equals to 24. Okay? Think of the answer that you find is a unique one. It's like you are finding a husband or wife, right? It's 1 in a million. It's a unique answer. It won't be okay, I let x be, I let this one be 24, then it works. Okay? So it's you have to make the right-hand side 0 in order to summon the zero product rule. Can, huh? So right-hand side must be 0 when you solve quadratic equation. With that, I will go to the next question. So the next question I have is question, I believe is question 3. Question 3, right? Question 3 is at the bottom. I'm just going down the row in order. So in case, can I just ask, okay, it should be this question now. It should be this question here. May I know who asked for this question? Is there, am I at the correct question of the correct time practice? No one. So is it at the wrong question 3? Because I saw question 3 being put up. So don't have? Oh. Okay, so I put a question mark here first. The next one is question 5. Question 5 is also written here. May I know who asked for question 5?
Me.
Okay, thank you. Am I at the correct paper?
Yeah.
Okay, thank you. Okay, so let's see, take a look. Okay, so for the numerator of a fraction is 5 less than the denominator, and the sum of the fraction and its reciprocal is 2 and 25 over 104. If the denominator of the fraction is x and x is positive, right? We write down the sum of the fraction and the reciprocal in terms of x. So they are basically asking us to write down the sum of the fraction and the reciprocal in terms of x. So what I do here, okay, of course, since they have told me that the denominator is x, I'm going to use that as a pivot to start off my journey. I read down the question, so I know that if the numerator of a fraction is 5 less than the denominator, my denominator will be x, and my numerator should be x minus 5. Okay, since they tell me that the numerator is 5 less than the denominator. The sum of the fraction and its reciprocal. When we talk about reciprocal, the meaning of reciprocal means we are taking 1 divided by that number. Okay, so let me give you an example. The reciprocal of x is defined as 1 over x. The reciprocal of 2 would be 1 over 2. Okay, and similarly, if I give you something like, what's the reciprocal of x minus 5 over x, right? Which is the number in our mid story, right? It will be 1 over x minus 5 over x, which is actually the same as x over x minus 5. Basically, I just flip my fraction. Okay, so far okay, huh? So the reciprocal part, I hope I addressed it. Okay, that's a tough one to crack. So the sum of the number and the reciprocal. Okay, so basically this is the sum of our fraction and the reciprocal over here. Okay. Okay, so this is my part A. My part A is done. Okay. So of course there's more to go. And they say that the sum of the fraction and the reciprocal is 2 and 25 over 104. Personally, I like to have my numbers as improper. So this will be 208 plus 25, which is 233. This is the same as 233 over 104. Why do I have that? Is because I like it as improper. I like it as improper because it's easy for me to cross multiply. Okay. As per what Ling Xuan was asking, that type of question she was asking earlier, and the type of question you were asking earlier also, it is, the same flavor where we have to deal with the variable first. We have to bring the variables into one family before we can cross. So from here, notice how the denominators are different, and I have to make them the same. Okay, I'm going to put them together. I'm going to put my two fractions together so that I can cross multiply. Looking at x and x minus 5, what I need to do is I probably need to multiply by x minus 5. And I square this because I'm multiplying x minus 5 by x minus 5. Over on this side, in order to get the common denominator, I will need to multiply by x and multiply by square. So far, so good? So far, so good. Is it okay? Cannot. I can't see your full face, so I can only see your forehead. So when you're nodding, I can't really see. Okay. If you can, you try to bring your camera down a bit. Okay. So now that my denominators is the same, and what I'll do is, okay, now I'm going to put them together. So my x minus 5 square plus x square over x minus 5 is equals to 233 over 104. Okay. Let me just expand this. So this will give me x squared minus 10x plus 25. Combining x squared and x squared, this should give me 2x squared minus 10x plus 25 over x bracket x minus 5 equals to 233 over 104. Okay, now it looks really not easy, but don't worry, we can do it. All right, so let's just, even though the numbers are big, let's try to crunch them together. Okay, you can see all I'm doing here is just to really unite all my algebraic fractions, so that they come together as one family. Then I can cross multiply. Only in this stage, cross multiply is so easy, which is why I'm putting them at one fraction first. And this part is like so-called JH2, right, where we did all the difficult part of putting them together. And from here, I cross multiply. There is 233x bracket x minus 5 equals to 104, 2x squared minus 10x plus 25. Maxine, so far okay? Still got you? Cannot. Okay, so those who have just joined, just to let you know, I'm going through the time practice, not the time practice paper 1, but time practice question 5. Okay, so from here, 233x to x, that will be 233x squared. 233x to negative 5, let me see, 233 times 5, that is minus 1165x. On my right hand side, 104 to 2, that is 208x squared. 104 to 10 minus 1040x, 104 to 25. I use calculator. The answer is 2600. Even though the numbers are big, don't worry. Okay, slowly go them, eat them one by one. Okay. And after that, as per all quadratic equation, like I've said it a few times in this lesson, I hope you caught the hint, is that we always try to push the end goal, right? The end goal. Why does Maxine, sorry, can you ask your question again? What does it mean? What do you mean by the question?
Why does x squared equals to 10x plus 25?
Are you referring to line number 2?
Yeah.
Oh, this one is a minus sign. X squared minus 10x plus 25.
Okay.
You know, because what I'm doing here when I take x minus 5 square is I actually employ the identity expansion a minus b bracket square. Okay, cannot. So this one is a minus sign. Cannot. It's actually minus sign. So far, okay? Cannot. Okay. So then with that, we go down the expansion, we go down the tearing apart of all the brackets, and slowly I'm going to put everything together. Personally, I like my x squared positive, so I'm going to bring this one over instead. I'll bring the smaller guy to the bigger guy. So 233 minus 208, that should give me 25x squared on the left-hand side. Okay, so this one goes over. It will be like minus 208x squared. Okay, 1040 goes over. It will become like a plus 1040x. So this is 1040 minus 1165, which gives me a minus 125x. 2600 goes over to the left. It will become like a negative 2600 minus 2600 equals to 0. This is my final equation, which is, as you see, my angle. My angle is to have it in this form. Okay, my angle is what they want. Okay, I'm supposed to show this. Okay, I'm supposed to show this. They know I'm supposed to show this. Okay, so this is what they want me to show. I'm going to put it here in front of you. Okay, this is what they want me to show. Am I there yet? Almost. Perhaps if I divide all by 25, I divide all by 25. You can see if I divide all by 25, divide 25, divide 25, divide 25, and yes, nice. X squared minus 5x minus 104 equals to 0. Therefore, shown. And this is actually my part 2. Okay, you can see this is my part 2. I have done this part. Okay, mission accomplished. Hence, solve the equation and find the fraction. So what we want to do now is we want to solve for the fraction. Okay, so I'm going to use the quadratic formula now. So I can see that A is equals to 1, B is equals to -5, C is equals to -104. Using my formula, X equals to -B plus minus square root B squared minus 4AC over 2A. Okay. While doing this, of course, you know that what I'll do next is I'll of course use the calculator to play cheat. Okay. So calculator 1, -5, -104. X will be equals to 13. Okay. So x equals to 13 and x equals to -8. It means that this equation, okay, from calculator, x equals to 13 and -8. This is what I don't show. I just do it on the side. I don't show the teacher. That means I write down x plus 8, x minus 13 equals to 0. So x equals to -8 or x equals to 13. Okay, but I have to take note, this is rejected because x is positive. Okay, as you are doing, you will find that you are always, you can see how I'm moving my iPad. I'm always jumping between the answer and the question. Question says that x is positive. Okay, question says that x is positive. So bring it down, you see, therefore, if x is positive, this is the part where we must reject. Okay, they tell you that x is positive. Okay, so we reject this. Therefore, my x is 13. Find the fraction. Remember our original fraction in algebraic form is x minus 5 over x, right? Meaning it should be 8 over 13. And we are done with question 5. Okay. Let me put the whole question out so you can see. This is question 5 of quiz 1 time practice, the one about the fraction. Let's see if I can go on, then you just let me know. Okay, I think you are copying, right? Or writing down some corrections, so I'll just pause a while. For paper 2, paper 1, I may need you all to help send me. Okay, I only got I seem to only have this one. I don't know where's the other one. I have it in hard copy, but I left it in school. So sorry for that. Okay.
Okay, you can go on.
Thank you. Okay, so next one I believe is question 7, I think. Question 7, right? Question 7. And question 6. Okay, so I'm just following based on my handphone. Okay, okay. So far I have done this. I think I have done this. I have done this. I have done this. Okay. Question 6. Airplane is flying. Oh, quick check. May I know who asked for this question? Me. Who? Oh, Li Xuan. Okay. An airplane is flying to the destination. Okay, can I just check which part is bothering you? Parts.
Every part.
Every part. Okay.
Like wait, there's the part C.
It's part C is the one bothering you, right? My guess.
Yeah.
Okay. Can. Don't worry. So let's take a look. My guess is from my understanding of you probably did part C, but you got stuck. It could be either the fraction is in the wrong order, or it could be you make some careless mistake when you expand the brackets. Okay. So after I go through, if you need to, you send me your question, your solution. I can go through and tell you where the possible overlook should be. So I fly to a destination 3,000 kilometers away. The speed of the airplane is in still air. It's still air. So why do they put still air? So that you know that there's no wind assistance or wind resistance. Okay. And the speed of the wind, which is constant throughout, is x kilometer per hour. Write down in terms of x for the time taken by the aircraft in hours if it is flying against the wind. So what I'm saying is this. Okay, when you fly against the wind, right, the wind will slow you down. Just like when running, you know, if the run and the wind is blowing against you, it will make you slower. So then the time, right, is distance divided by speed. And the speed here will be 500 minus x. So far, so good? Can, huh? Now, but if I'm running in front with the wind behind me, it feels as though I got a booster. So the wind is going to push me forward. So I'm like a leaf. Okay, of course I'm too fat now, but if there's the wind behind you, it will push you. It also helps you to increase your speed. Okay, with the wind, of course, you go faster. So you can see that here, the time definitely will be shorter because I have a faster speed. The speed now is 500 plus x. The difference in time is 45 minutes. So what I'm trying to say is if I have the difference in time, right, versus against the wind and with the wind, it should be the bigger number should be the one that's against the wind. This is going to take more time. Versus with the wind, it will be a smaller fraction. Okay? Quite obviously, you can also see that this is a smaller denominator. This is a bigger denominator. This is bigger in value. This is against the wind. Against the wind. Against the wind. And this is with the wind. Okay? And this time difference is 45 minutes. So a rookie will go and write down 45 and then they start to solve. Okay? But you must note that this is in minutes, but the whole question is talking about hours. Right? They are all using hours. They are all using hours. So if I follow that, you go to Rome, you follow what the Rome do, right? If they use 45, of course, I have to change mine to 3/4 of an hour. Okay? So that is one of the possible mistakes that people make as well. And a second mistake is people wrote in wrong order. They wrote this at the front instead. Okay, don't know if I caught any of the of your mistakes of Nishan. Okay, so from there, right, then again, before I mingle with the one on the right, I'm going to really put them as one fraction. Okay, yeah, I put this as one fraction before I actually go and simplify. And you will see that here, what I'm doing is I'm going to take 3000, I'm going to multiply by 500 plus x minus 3000 multiplied by 500 minus x, all in good faith of trying to create a common denominator. In good faith of creating a common denominator. Is that so far okay? Cannot in good faith for creating common. And I'm still not going to bring a 3 over 4 over first, because I'm not ready to. I tell 3 over 4, I'm not ready yet. You wait outside first. Okay, this one I must simplify. So 3,500. Wow, that's a big number. Wow, it's probably also, to be careful, I also use calculator. That gives me 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 zeros. Okay. Plus 3000x. Subtract. Again. 1, 2, 3, 4, 5. Added to 3000x. Okay. Denominator is so nice. It's an algebraic identity. So I was just going to write 500 squared minus x squared. Okay. So you can see how beautiful when the brackets are together with opposite signs. This and this cancels off. And my numerator is just 3000 plus 3000, which gives me 6000x over 250000 minus x squared equals to 3/4. So far, okay? After that, okay, I'm ready. I'm so simplified now. It's like you've taken a bath and all the dirt just ran away. So I've simplified all the disgusting terms until I've got a very, very nice and beautiful and humble, clean, simple equation. This is where I cross multiply 6004. This will be 24,000x. Okay, the one in the red, I'm going to bring it to the right. Over here, this is the blue. So 2005 and 3, 75,000 minus 3x squared. And with that, oh yeah, I made a mistake. Did I make a mistake? Okay, I see I couldn't get the equation now. Okay, I made a mistake. Oh yeah, I did. It's fine, Okay, so then from here, let me go on and add another box. Okay, so I make 3x squared, bring it over, bring 75 over, that'll be minus 75,000, 750,000, sorry, plus 24000x. Can I? I'm just bringing the red guy over, transform, make it positive, because I like my x squared positive. I'm just bringing 750,000 over so that I can get my equation in the form of ax squared plus bx plus c, which is my favorite starting point before I solve any quadratic equation. All right, so of course, the question has some requirement. They make us reduce to this, which you can see I'm there already. Okay, just look at where I am. I am there already. I am there already. Okay, just look at my equation now. All I got to do is so simple. I just divide by 3. I just divide by 3. So dividing by 3, divide by 3, divide by 3, and you can see how I have x squared plus 8,000x minus 250,000 equals to 0. Therefore, shown. Okay, man? Can hold. And I'll probably leave the rest to you. Can I? Okay, I think the rest are good, but you should be able to handle. Okay? So next, I will go to, what's the next question I should go through? question 7. Is it question 7? 6 is done, huh? So 6 are done. So question 7. May I know who asked for question 7?
Me.
Sorry, who? Did someone's who's the again? Sorry, who asked for question 7?
Me.
You are wait, is it Tunsheng? No, Tunsheng. Tunsheng, right? Okay, okay. Sounds like Tunsheng. Sorry, my camera all at too small. So the graph of, oh, this is a hard one. Okay, see, got chili there. It means it's hot. Higher order thinking. So the graph of 3 plus ax squared plus y plus b squared equals to 10, and b equals to negative y minus 1 plus ax intersect at the point negative 1, 3. Okay, on first side, it looks as though like we're solving for x and y, but we're actually not. So intersect at the point, right, it means that this actually represent xy coordinates. Don't you think so? Right, they represent xy coordinates. However, in this situation, right, they actually coded the a and the b such that the a and b are unknowns. Okay, so if they say that these two graphs, right, intersect at the point negative 1, 3, it means that, you know, on the xy plane, you probably can visualize that two of them are having a party. Maybe one is here, that is your 3 plus ax squared plus y plus b squared equals to 10, and another graph, maybe something like that. Maybe the other line is b equals to y minus 1 plus ax, and they actually meet at this point, which is negative 1, 3. That's how it looks like. Okay, just a visual. So what does this negative 1, 3 signify? It signifies xy coordinates. It signifies xy coordinates. And what does it do is, with this point, right, this one is actually very powerful. It satisfies this equation as well as this. Okay, it satisfies this equation as well as this, meaning I can substitute them in. Okay, so I'm going to take the first one. You can see I'm going to take the first one here. Okay, and I'm going to substitute my y as 3, right? Because y can be 3. I'm going to substitute my x as 1, because x can be 1. Now, similarly, if I take this equation here, it also passes through the same point. I'm going to take my x again and substitute negative 1. I'm going to take my y and substitute 3. Oh, sorry, shit, wrong. Okay. Cancel the wrong one. Okay, I'm going to cancel off the y, and I'm going to write 3. So far, so good. Tuition so far okay? Tuition so far okay? Are you nodding here? Are you nodding here? You're nodding here. If okay, give me a thumbs up. Tuition so far okay? Tuition okay, can. So from here, maybe let's call this equation 1. And from 1, let me just try to create a sub. Now it looks pretty messy. It looks like 3 negative 1 plus a. So maybe write it as b equals to 2 plus a. Let's call this equation 3. Equation 2. Now I sub, then I'm going to sub 3 and 2. Okay, I'm going to substitute 3 into 2. Okay. And from here, I substitute 3 into 2. This is 3 minus a squared plus 3 plus b squared equals to 10. Okay, highlight, this is my b. This is my b, the sub that I introduced into the family. Okay, so this portion, this is a squared minus 2ab plus b squared. This portion, this is same as 5. This is the same as 5. 3 plus 2 is 5. 5 plus a bracket square, again in black, a square plus 2ab plus b square equals to 10. So far, so good. Okay? Can next, simplify further. Okay. So again, like I was saying, in all my questions here, My personal favorite is to have it, all my quadratic equation in the form of ax squared plus bx plus c equals to 0. I make sure one side is 0. Okay? Combining a squared, that gives me 2a squared. Combining negative 6a and 10a, that gives me negative 6 plus 10, that gives me 4a. Combining 9 and 25, that gives me a 34. Oh, I have another 10, which I forgot to bring over. Sorry. I bring over this 10 here, it will become a minus 10. So minus 10 minus 34 minus 10, this will eventually give me 24. Okay, so 2a squared plus 4a plus 24 equals to 0. Seeing how everybody has a common factor 2, I'm just going to divide by 2. And this is a squared plus 2a plus 12. Okay, equals to 0. Simplify further. Can I do it anymore? Probably that's about it. That's as far as I can go. Okay, so where a and b are non-negative integers. A squared plus 2a. Is it a nice number? Did I make any mistake? Let me see. 3 plus b. 3 plus b. 3 minus. Oh dear, sorry. 3 minus a, 3 plus a. This one should be 3 plus 3 minus a, my bad. Thank you. Sorry, this is 3 minus a. So this is 3 minus a. Okay, my bad. So I made a mistake in the b. It should be 3 minus a. Let me redo again. Okay, so 3 minus a. So my b is 3 minus a. My b is here. Okay, so quickly, 3 minus a squared plus 3 from equation 2 equals to 10. My y is 3 minus a squared. Okay, from this one, wait, correct. B equals to y minus 1 plus y minus 1 minus a. B equals, oh no, it's wrong. It's correct. Okay, it's correct. Okay, so I make 3 minus 1 minus a. 3 minus 1 minus a. 3 minus 1 minus a. 3 minus 1 is 2. 2 plus 2 minus a. 2 plus, oh, this is minus 1. So therefore, this is 2 minus a. 2 minus a. Therefore, this is a minus 2 minus a. My bad, this is 2 minus a, okay? So therefore, this is 25 minus 10a squared. 10a. So therefore, erase again. Minus 10a and minus 6. That should give me minus 16a. 9, 25, 10, 24. 24 as a 24. Then I have a squared, that's 2a squared. Equals to 0. 2a squared minus 16a plus 24 equals to 0. A squared minus 8a plus 12 equals to 0. So a minus 6, a minus 2 equals to 0. A equals to 6 or a equals to 2. Solution okay, man? Sorry, I made a careless mistake. So I make up for it. I remedy on the spot. Okay. May I go on? I pause a while. Okay, look like you're looking at the screen. I can't see your eyes, but I think you're looking at the screen. So shall I go on? Can I? Okay. Okay, so next one, I guess is 7 is done. I've done 6, I've done 7. Question 8C, part 2, part 3. Huh? May I know who asked for this? Am I right to say this too?
Me.
Diction, huh? Okay, okay. So the variables x, y are connected by this equation. Okay, so I use my graph to solve the following equation. Okay, so of course, I don't have graph paper on my iPad lah, so I'm going to try to cheat as much as possible. Okay, so the idea is that in part 2, you have drawn, in your earlier part, you have done the hard work. Okay, make sure you bring your curve through all this tomorrow. Huh? Yeah, because after all, curve plotting is in the test scope. Huh? Okay, so this is the one that you draw. Okay, so what you want to do is, if you look at this equation here, 2 minus x, 5 plus x, the strategy is to try to create this graph and make it appear again. Okay, so in my part 2, C part 2, this is what I have. If I were to divide by 2 on both sides, right, this is the same as half of 2 minus x, 5 plus x equals to 5 over 2. Right? So why do I do that? It's because this is the one that was shown. This is the original one. This is the original one that was shown. So Ling Xuan, if you think about it, if you just sketch, you have this graph that was there. If you just sketch this graph, right? Think about it. If you just sketch y equals to 5 over 2, right? Then having these two on your graphs, right? That point of intersection will be the solution already. Don't you agree? Correct. So by sketching this additional graph, it's so powerful. The additional line there, which is a horizontal line, allows you that point of intersection can solve the equation straight away. And if it solves this, right, it will solve the original equation. Okay, so basically the strategy is that from the question given, right, you work backwards, right, by divide to get the original question, which is here. Okay, if your original question or the original equation appears, whatever is on the right, that is what you will draw. That is what you will draw. Okay, that is what you will draw. So far, okay, man? Okay, cannot. This question is very difficult. So if you are not clear, just let me know. I can say it one more time. Okay. Now, okay, this 2 minus x and versus 5 plus x. Let me just do it at the side. This one should be 10 plus 2x minus 5x minus x squared. So it's 10 minus 3x minus x squared. Okay, so I just want to tell you that when I expand this, right, it sort of looks like this. Okay, the red part. So because when I saw this, I know that in the expanded form, this is going to look a bit like my original question. Okay, so x squared in C part 3, this one should be the part 3, plus 3x minus 10 equals to negative 10, right? If I were to factorize it, you can see that this is like the negative of negative x squared minus 3x plus 10 equals to negative 10. Is that okay? I factorize our negative sign. Because why do I do that? Because I had this in my mind. I had the original in my mind. If this bothers you, then never mind. Let me go back to the start. This, if I factorize, is x plus 5, x minus 2. This one manageable, right? So again, because when Ling Xuan is doing this, she will have the start point in her mind. She will think of how do I get from here to here? Okay, so 2 minus x, x minus 2, I probably need to multiply x minus 2, right? Is the same as the negative of 2 minus x. This part cannot. So this is what I'm going to do. You notice I'm going to slowly change this. I put a negative outside. 2 minus x is equals to negative 10. Right hand side, I still never touch. I never touch anything. Okay. Again, with the question in my mind, okay, I need a half. The minus sign has to go away. So this is where I start to mingle already. Minus and minus can both cancel off. Okay, now I'm going global. I'm going to take away minus on both sides. I look at my original question. I still need a half. So I multiply by half. And on my right hand side, 10 multiplied by half is just 5. So I'm going to draw the line y equals to 5. Okay? Can I? Okay. So with that, question 8 seems to be good. Okay, okay. Do you need to copy? Or you need to pause a while? Yeah, copy. Yeah, pause a while. Okay. I'll just pause a while for 1 minute. I drink some water also. I've gone through almost the whole paper. Okay, I've gone through almost the paper. I'm downloading the Friday's lesson. Just give me a while. Later by tonight, I promise I will send out the video to you. Okay, for both. Okay, I'll put on YouTube. Question 8, I go through. Then there's question 9. Question 1, 3, everything I go through.
Already.
Okay, okay, thank you. So next one is question 9. I think that's the last one for this paper. After that, we'll be going on to the quiz. Unfortunately, I need your help to send me the question for the quiz. I forgot to print out the soft copy. Okay. Okay. A solid hemisphere has a radius of 3p and a total surface area of 912 cm squared. Okay. Can I ask for your help? May I know who asked this question? Am I at the right test paper?
Yeah.
Correct. Okay.
Yeah.
So from here, okay, I want to find the value of p. Okay. Of course, based on this, right, the information that I'm going to use is what I find in the question. And of course, some of it will come from me. What do I know about hemisphere? Hemisphere, right? Hemi comes from the word demi, semi, right? It basically means half. All right. We don't say semisphere, we say semicircle, demi, semi, hemi. They all mean half. So you're talking about a big watermelon that's cut into half. Okay. So if what does a solid hemisphere look like is you will see that the surface area consists of the top part that in itself will be a pi r square. It will consist of the curved part, and the curved part would none other be half of the surface area formula, which is like half of 4 pi r square. That okay with you? Can I? So this is the surface area of a hemisphere. Okay, I will say a hemisphere, a hemisphere. And from here, right, okay, half and 4 cancels off, which is just 2. And I get pi r square plus 2 pi r square. And wow, it looks so nice. It's just 3 pi r square. Okay. So this is my semi-area of the hemisphere as a formula. What else do I know? Okay, I'm supposed to find P. What do I know about P? Well, P is the radius. So, and the total surface area is 912, right? So I'm working from the right-hand side. This is supposed to be 912. So by right, 3 pi, my radius is 3p squared, right? This is my radius, This is my radius, right? This is my radius. Okay, in terms of the question context, right, is equals to 912. Okay, 3 pi r squared is 912. 3 pi r, because r is 3p, okay, is 912. So be careful how you manage the 3 also. Okay, it's basically a 9 square. So 3 square is actually a 9. It's something like a 3 pi times 9p square, 912. 9 times 3 is 27. 27 pi p square is 912. P square would be 912 divided by 27 pi. Oh, why I write 27? My brain and my hands are not coincide. Okay, 27 pi. Okay, I divide by 27 pi on both sides. Divide by 27 pi on both sides. And with that, in order to find my p, I just need to square root. So I'll just go to my calculator. I key in what is square root of 912 over 27 pi And my answer turns out to be 327.899. I'm not looking at the answer, so if I make a careless mistake, do let me know. Okay, I'm doing it as I'm going through with you all as well. So far, okay? So far, okay? It's part out. Okay, I just pause a while. Look like you're copying, so I pause a while. "24 of these hemispheres are melted to form a single hemisphere." So what it tells me is, okay, you're like putting 24, it's like a bath bomb, right? You put 24 inside, you make a very big hemisphere. Okay, so they are actually talking about part one, they test on area, part two, they are testing on volume. All right. So if basically in the second part, right, when we take we calculate the volume of one small hemisphere, okay. A volume of a sphere is 4/3 pi r cubed. Remember, the volume of a sphere in itself, the formula is 4/3 pi r cubed. The volume of a small hemisphere, I have to divide it by 2 because we are only getting half the watermelon. All right, it's 2/3 pi r cubed. Okay, and note that in my small hemisphere, the radius is 3p. All right, it's 3p. So it's actually 2/3 of pi of 3p. So take note, this is my p, which I found earlier. 3 times 3.27899,384 power 3. So far, okay? This is my radius. Okay, because my radius is 3p, and this is the p that we found, which is 3.27899,384. Okay, I'm going to calculate that for you. So just give me a sec. Times pi times 3 times 2. And this is what I got. My answer is 202. Okay. And this is the answer that I got. Okay, so it's over here at the side. This is 202. And it looks like 202 and 2/3. Okay, let me just put it at 667 now. 66667. Okay. Now this is for one small hemisphere. Now I need 24 hemisphere. So if I take the volume of 24 small hemispheres, okay, basically I need to take this one multiplied by 24. I'm going to take this multiplied by 24. Answer gives me 4864. Almost approximately this is the volume to 3SM. Okay, even to 6SM is almost the same. Okay, 4864. This is the volume of the big hemisphere because I melted 24 of them to give you a big hemisphere. Okay, now Carl thinks that the radius of the large hemisphere is 24 times 3p. I want to show that Carl is wrong. Let me see. 24 times 3p. Oh, is it possible that okay, show that Carl is wrong. Okay. So this is the volume. Okay, let me call it a second one, which is maybe R2. Okay, so if I talk about volume of the big hemisphere, let me use a different R. Okay, so this is by right 2/3 pi. I call it R because big hemisphere cube. Okay, supposedly is 4864. Okay, now you calculate this. You take 4864 divide by 2/3 pi. That's supposed to be R cubed. And you find that R is just the cube root of 4864 divided by 2/3 pi. Okay, so let me do that in front of you. If I divide by 2/3 pi and I cube root the answer is actually 13.24275. This is the radius of the big hemisphere. Okay, you can see that this is not equals to 3p. It is not equals to 3 times 3.27899. Okay, 3.278998384. Or 24 times 3p. He thinks that the radius of the large hemisphere is 24 times 3p. So you can see that this is not equals to 24. This is not equals to 24 times 3p. Okay? 24 times 3p, which is 72p, supposedly is equals to 236. It's far away. It's far away from this. This is the actual radius. This is 24 times 3p. So far, okay? That's why they are different. Okay. To show where I can go on, you let me know. I'll just pause here for a while for you to copy. So that's question 9 for you. And okay, I think I have finished. Okay, someone asked for paper 2 question 4 and paper 2 question 1. Is it okay you send me the question? Paper 2 question 4. Okay, if you have sent me any, then no. Okay, wait, my phone is paper 2 question 4. I don't have the paper 2 question 4. Okay. Paper 2 question 4. Okay, let me look at this one first. Where is this question from again? Quick one. Ling Xuan, quick check. Where is this question from?
The
Oh, okay. Past year quiz. Past year quiz, is it?
yeah.
Thank you. Thank you so much. Okay, so this is the past year quiz. Okay, yeah? So in case everybody you are wondering, this is what I'm going through. Here we go. Hamza, if you can send me the question, okay, huh? Okay. So I've gone through all this. This one, 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 this one. Okay. So I'm left with. I've gone through. So I'm going through this one now. Okay. Okay. So I need help to send me these three, 1, 5, and 7, 5. Thank you. Thank you. Sorry to trouble you all. Okay. So question 1 is the question 3. 2x squared plus 12x equals to 4, followed by x squared plus 6x equals to 2. Correct? Equals to 2. Okay. Second, explain the mistakes. Okay. So nothing wrong. X squared plus 6x plus 3 equals to 4 plus 3 square. Okay. So nothing wrong. Here to here, nothing wrong. Here to here, plus minus, correct? Here to here. Because of that, this should be x equals to 3 plus minus square root 30, which is x equals to, your answers are correct. Lishan, so what is bothering you with this question? Your answers are correct. Yeah. They're good with me. They're correct. So you identified the correct mistake, which is this and this. But from here to here, yes, the next step is correct. From here to here, the next step is correct, even though they use the wrong starting point. So your answers are correct. Your answers are correct. So yes, here, by right, this should be 2, not 4. Okay, because they divided by 2. Okay, so here you put 2. The 2 has to be outside. Here to here, can, no problem. Here to here, he forgot a plus minus. That's correct as well. Okay. Okay, can, yeah, so just to assure you, answer is correct. Answer is correct. Okay, so no issue. Okay, correct. Okay, so Ignatius sent to me. Thank you, Ignatius. Okay, time practice 1 question. Time practice. Okay, so now I need to go through this one. Time practice 2, question 1. Time practice paper 2, question 1. Okay, may I know who need help for this question? Oh, okay, can. Okay, so for this, right, part 1, let me check. Wait. Okay, wait. Ignatius, I just checked part 1, part 2, or part 3? Part 1, or part 2, or part 3? Or part 2, right? Part 2, huh? Okay. Okay, so part 1 is good for you. Part 1 is good for you. Is part 1 good for you? Good for you. Okay, thank you. Okay, so let me wow, okay, I don't know the answer for part 1. Let me try. Okay, I also have to do it from scratch. I don't have the answer. So y equals to negative x squared plus 7x plus 18. I factorize out the negative sign. 7x plus 18. So I see a negative x, I add 3.5, 7 over 2 squared. I minus 7 over 2 squared outside. This gives me negative x minus 3.5 squared. And outside is 18 minus 3.5, which is 23 over 4. Okay, which is 23 over 4. Okay, so from here, sketching the graphs of this graph, okay, when it's in this form, I just follow. In this form, usually I follow SITL. Okay, when it's the factorized form, I will follow SILT. Okay, when it's the completed square form, I'll follow SITL. Simply because in completed square form, it's easy to see the T. Okay, and from here, first of all, I look at shape. The shape is a negative one because negative x squared. So far, okay? Can now. Next one is the intercept. So for the intercepts, to find the shape is a negative coefficient, right? So coefficient x squared is negative coefficient, meaning it's a set face. Now, next one is I. I for intercept, I look for the x intercept, I substitute y as 0. So if I sub y as 0, right? 0 will be negative of x minus 3.5 squared plus 23 over 4. X minus 3.5 squared will be equals to 23 over 4. This is by bringing this over to the left. Square root both sides. X minus 3.5 is plus minus square root 23 over 4. And therefore, x is equals to 3.5 plus minus square root 23 over 4. Okay? So, yeah. So my answers, one is here. 3.5. Okay, 3.5 square root 23 divided by 4. Okay, approximately the answers is something like 5.8979. And 1.10208. Okay, so this would be 1.102. This is probably 5.879. Okay, no particular restriction on the number of significant figures. 3.5 will be somewhere here. That would be my turning point. Okay, so I'm going to T. Okay, I'm going to T. 3.5 will be turning point. Okay, so I'm going to T because from here, if you all recall, just identifying these two numbers, right? Okay, the negative of the inside, that's the X coordinate. Outside, that's the Y coordinate of the turning point. Okay, and from here, last one, L, S-I-T-L. L is the line of symmetry, which basically is just passes through the turning point. Okay, and from here, oh, wait, sorry, I forgot the Y intercept. Sub X equals to 0, your Y is negative 0 minus 3.5 square plus 23 over 4. So sorry about that. Negative of 3.5 square plus 23 over 4. This is minus 13 over 2. So somewhere here. Sorry, my graph very bad. Okay. Somewhere here. Do I have a ruler function? Ruler function. Okay. Yeah, okay. Okay, so from here, this is my Y, negative 13 over 2. Okay, then with that, I'm done. This is my graph. Can so with this, right, without further calculation, write down the sign of the discriminant. As you can see here, right, we have two intersections. This means that we have two distinct real roots, and the discriminant will be more than 0. Because if discriminant more than 0 is two real and distinct solutions. Okay, that's the classification. Discriminant equals 0, touch 1 point. Discriminant more than 0, touch 2 points. Discriminant less than 0, no solution at all. Okay, can I? Nations okay? Can I? Okay, should I go on? Or do I stay? Okay, I go on. Okay, thank you. Next one. Okay, so I've gone through this one. Okay, question 5. So I'm going to go to time practice paper 2, question 5. Okay, I saw my own face. I got scared. Okay. Sorry, let me just read. The answer sheet said that it was a different answer for question 1. Can I just check, Hamza? Are you referring to the one that I just went through? Check. What's the answer again? Sorry. Because the answer for part 1 is a graph, so unless I made a mistake, let me see. Did I make any mistake?
I sent it on WhatsApp.
You sent it on WhatsApp, huh? Let me think. Meaning 7 over 2. Oh, did I make? Oh, sorry. Is it 18, huh? Wait, 18 plus 3.5 square. Correct. Oh, yeah, you're right. 1 to 1 over 4. My bad. Thank you. 1 to 1 over 4. So this is 1 to 1 over 4. 1 to 1. Okay. So this one is 1 to 1 over 4. That means these two also will change. These two also will change. But basically, besides that number that's wrong, everything else is the same method. Okay. Thank you. Thanks, Hamza. Okay. I did it without looking at the answer. So I promise you I'm doing it as like I'm doing the studying for the test like that. Okay. Okay. So okay, then next one I'm going to go to question 5. The diagram below shows a composite solid. This is from time practice paper 2. Time practice paper 2. It shows a composite solid made up of a cone and a cylinder. The ratio of the height of the cone to the radius of the cylinder to the height of the cylinder is 3 to 1. So, oh, very good. So this is drawn 3 unit, 2 unit, 1 unit. Okay. The slant height of the cone is 9, and the radius of the cone is, okay, The start of the cone, okay, can. Is the radius of the cone, the radius of the cylinder and the radius of the cone, isn't it the same? Okay. The radius of the cone and the radius of the cylinder, isn't it the same? Okay, that means 4.9923. The solid is melted to form a sphere. Justify if the newly formed sphere. Okay, let me find the volume of this. Okay, so they tell me that why do they give me the start height for what? Okay, so maybe no need. Okay, so the radius of the cone is 4.99223. Isn't the radius of the cone the same as the radius of the cylinder? The radius of the cylinder is 4.99223. Okay. First of all, this is my assumption. The radius of the cone should be equal to the radius of the cylinder as well. Because I see that they are both the same. Okay, unless there's some tricks that I don't know about. And I suspect that this 9 is not needed because I suspect that it has to do with Pythagoras theorem, but it's in a cut off, it's in a later part of the question, which they cut off. Okay, so not to worry about that. So if they tell me that the radius of the cone is 4.99223, then I can also say, because this is by right 2 units, right? Then by right, the height of the cone will be 4.99223 divided by 2, then times 3. Right? Because the height of the cone is 4.9923 divided by 2 times 3, which is 7.48845. Then the height of the cylinder, which is 1 unit, right? It's 1 unit, right? This is 3 unit, this is 1 unit, would be 4.9923 divided by 2, which is 2.49615. Okay, this is assuming this. Now with this, right, my overall, I'm going to add the volume together. The volume of my cone will be 1/3 pi r squared times height. 1/3 times pi times r squared times height. My height is 7.48845. My cylinder is volume is pi r squared times cylinder height, which is 2.49615. So far, okay? So far, okay? Sorry, who asked this question? I forgot. Is it? Oh, yes, okay, can. So far, is it so far okay? Can, so I based on the fact that it's 4.99223 is 2 units. Therefore, this is 3 units, this is 1 unit. I calculated the rest. And I'm going to calculate the actual numerical volume now. So I'm going to take calculator. Pi over 3 times 4.9923 squared times 7.48845. This part is 1.195.443822. This is the volume of the cone. The volume of the cylinder is just pi times 4.9923 squared times 2.49615, which is 195.44. Oh, it's the same. Okay. So if I times 2, the total volume is this plus this. Okay, the total volume is 390.8876045. Okay, yeah. So if I'm going to use this melt this solid to form a sphere, right? In the new sphere, volume of sphere is 4/3 pi. I'm going to use capital R, R cubed, because it's a new radius. This is the new big sphere, the new sphere. Okay, R cubed would be this 390.8876045 divided by 4/3 pi, and If I cube root this answer, finally my R is 4.5358. Okay, so this is my radius lah. So if you see my cube, right? My cube is of side 4.5, right? 4.5 by 4.5, right? You're trying to fit a sphere inside, right? This radius, right, is already 4.358. But if I talk about the diameter, it's going to be 2 times 4.358, which is about 9 cm plus. This one confirm cannot fit because the radius is already almost same as the size of the box already. So you can see if the radius is 4, right? Because when I fit in the sphere, right, it has to fit in like with the diameter has to fit in, not just the radius. The diameter of the ball has to fit inside. So the diameter of my new sphere is 9 cm something. Is 2 times of the radius, right? Which is 2 times 4.5. Therefore, answer is no, cannot fit in. Okay, answer is no, cannot fit in because the diameter of the sphere is over 9 cm. It cannot fit into the box of side 4.5. Do you follow so far? Yeah. Can hold. So I'll pause a while at this question. This is where I can go on. You tell me, okay? You need to copy that. Sometimes I go through a time quite intense. Like you see, I talk non-stop there. I too fast, and you just tell me. Okay. So, okay, I go through this one already. Past year quiz question 7. Past year quiz question 7. Did anyone send me a quick past year quiz question 7? Did anyone send me past year quiz question 7? Who asked me to? Have I gone through? Oh, wait. Past year quiz question 7. Past year quiz question 7. Past year quiz question 7. Jolene sent me, right? Okay. The other 2 is question 7. Question 3 do already. So the other 2 is question 7. Question 3 I went through already. Oh, not very clear. Go. Okay, it's a bit blur from my side. Okay, never mind. Maybe I do from here. Question 7. Okay. Okay, maybe I just do because the photo a bit. So okay, basically there is one hemisphere. This is from past year quiz. Past year quiz. Question 7. Okay. Then the radius is x cm. Over on this side, the radius is x minus 4. There's another cylinder. The height is 5 pi over 2. Okay. So I'm supposed to show that the surface area of C is, I'm supposed to show that the surface of C is 5 pi 7x. Okay, so let me see. Surface area of a cylinder. Surface area of a cylinder will be basically the top, which is pi r square, bottom, which is pi r square. So it's something like 2 pi r square plus this rectangle, this like it's a rectangle here, it's like 2 pi r multiplied by 5 pi over 2. So it's like 2 pi r multiplied by height. Okay, so when you look at the curved part of a cylinder, it's like a rectangle. You wrap around the corner. Remember I did it in class. You open up. Okay, so in our question here, right, the radius is x minus 4 squared. Okay, in our question, radius is x minus 4 and our height is 5 pi over 2. So if I go on to open up this 2 pi, Okay, this is a square minus 2ab plus b square. Pi and pi, that gives me a pi square. 2 and 2 will cancel off. That gives me a 5 pi x minus 4. Okay. Open up further. 5 and pi, that gives me a 5 pi square x minus 20 pi square. Over on this part, 2 pi x squared. 2 pi to negative 8x, negative 16 pi x. 2 pi to 16, that gives me a 32 pi. And over on this part, wait, let me see. Is it 5 pi or 5x? I think it's 5x. Wait, Jolene, are you there? Jolene, I checked with you. This one is 5x, right? Not 5 pi, right? Sorry, I already, my eyesight not so very good. Okay.
5x.
5x, 5x. Okay, that made a mistake. Sorry. So one more time. This is 2 pi. R square is x minus 4 square. 2 pi r is x minus 4. This is x. H is 5x over 2. Okay. With these two, you can I see that is okay. Cancel out 2. Pi I factorize outside. Okay. So 2 of x minus 4 square plus x minus 4 multiplied by 5x. Okay, can I? Sorry, may I know who asked for this question? May I know who asked for this question? Oh, Geraldine, where are you? Geraldine, so far, is my pace okay? Cannot. If I lost you in the algebraic manipulation, let me know lah. Sometimes I go too fast. So x minus 4 square. Okay, I factorize on pi. This part 2 of a square minus 2ab plus b square x to 5x square minus 4 to 5x minus 20x. Okay. Then 2 to x square again, 2x square, 2 to negative 8, negative 16x, 2 to 16, 32, plus 5x square minus 20x. And you can see that I'm going to arrive there now. So this is pi, combining 2 and 5. That gives me 7x squared. Combining negative 16 and negative 20, that gives me negative 36. 32, nobody to play with, stays alone. And therefore, part 1 is done. Okay? Can hold. Let me just pause here a while in case you need. So this is the surface area of the cylinder. Geraldine, so far okay? Can I go on? Oh. Shall I go on? Oh, I wait a while. Okay. Yes, okay, go on. Okay. So in part 2, right, then they say that C and H have the same surface area. So in C and H refers to probably the other one. This is hemisphere H. This is cylinder C. H for hemisphere, C for cylinder. With this hemisphere, well, you know that hemisphere curved surface area is 4 pi r square. So sorry, I wrote wrongly. It should be 2 pi x squared. Okay. So by right, the surface area for a sphere, right? is 4 pi r squared. Hemisphere is 2 pi r squared. In this case, the radius is x, so it's 2 pi x squared plus the base, which is the circle, is the red color one. The one in blue, that is this one. Okay. So with that, they tell me that this is 3 pi x squared. It is equals to this, is equals to the one I found. Supposedly they are the same. So 3 pi x squared is supposedly equals to pi of 7x squared minus 36x plus 32. Okay, so I need to write down an equation and simplify. Pi and pi, I can cancel off. It's just a very humble common factor. I have 3x squared equals to 7x squared minus 36 plus 32. I'm going to bring my 3 over, so it's going to be a minus 3x squared. 0, 7 minus 3 is 4x squared, minus 36x plus 32. I divide all by 4, that gives me 8, and I am done. Okay, huh, Geraldine? Then from there, I think you can do the part 3. Part 3 will be quite easy because it's ask us to solve. Can, huh? Can, huh? Part 3 is just solve only, nothing much, so I think you can do it. Okay. Okay. Change slide slowly. So question 7 done. What am I left with? Oh, paper 4, question 2. Let me check. I have this. Question 5, nobody sent me. Let me check. Question 2. Anyone send me? Oh, okay. Question 4, paper 2. This is paper 2, question 4. May I know who asked for this question?
Me.
Okay, thank you. So, wait, me is Maxine, is it? Maxine, okay, can. Okay. So here, let me see. 3k squared minus 11k plus 6. Let me try to do a very humble factorization. I believe if I calculate 3 and 2 over 3. So this one is k minus 3. 2 over 3. 2 over 3 should be 3k minus 2. Okay. So again, what do I do is, this is like topic 1, part 4. I'm going to reduce the left-hand side. Okay, I'm going to reduce the left-hand side and put it into one equation first. 3 minus k. But before I reduce it into one equation, I might want to factorize my denominator to look for commonality. Okay, I look for commonality. Okay, oh, okay. Can you send me the question paper, the question? Can you send me the question? Thank you, thank you. Okay, so from here, I look at 3 minus k and k minus 3, right? Looks the same, but different order. So I'm going to do the same trick I did just now. Remember that a minus b is the negative of b minus a. So that means this is the same as negative of 3 minus k. All right, and with that, the plus and the minus can come together. So this is 7 over 3 minus k, minus 5 over 3 minus k, 3k minus 2 equals to 3. So the idea is that I can get a common. You see, I got common and common. So nice, right? And I don't have to do so much. I don't have to go and multiply them together. So, you know, I always say F and C. It's not fitness and conditioning. It's called factorize then cancel. Yeah, so factorize is, and you multiply, you can see that you multiply by 3k minus 2. Multiply by 3k minus 2. Okay? Put them together. So I have one fraction now. On my left-hand side. Okay, after that, not ready yet. I'm not ready to mingle the 3 yet. I look at my own terms. So am I on good terms? So this one, I might want to simplify. This is probably 21k minus 14 minus 5. Okay, because 7 times 3, 21k. 7 times minus 2, minus 14. Can see so far, okay? Can, huh? I still have you, huh? If I lose you anywhere in any step, let me know. Minus 14 minus 5, I can write it as minus 19. With that, now I'm ready to cross multiply. Okay, so the one in green, this is like 3 is like 3 over 1. So the one in green, let me put it on the right hand side, which is just 21k minus 19. Okay, 21k minus 19 times 1. Times 1. The one in red, let me write it on the left hand side. Okay, so it's 3 multiplied by 3 minus k, 3k minus 2. Like all questions, what I like to do is I like to put everybody on one side so that I have all in terms of 0, like ax squared plus bx plus c equals to 0, so that I can solve. Okay, so maybe I open this 3 to 3k. This 3 is here, this 3 is still here. 3 to 3k, that is 9k. 3 to negative 2, negative 6. Negative k to 3k, negative 3k squared. Negative k to negative 2, positive 2k. On my right hand side is 21k minus 19. Okay, open up some more. 3 to 9, 27k. 3 to negative 6, negative 18. 3 to negative 3k, negative 9k squared. 3 to 2, 6k equals to 21k minus 19. Okay, so slowly, I mean, I know that the journey is very long, so we take it step by step. If I bring my 6 and 27 over, this will be a minus 6k. Between 27 over is minus 27k. So if I combine 21 minus 6 minus 27, I'll have a negative 12k on the right hand side. Okay, now I take minus 18 goes over minus 18. Sorry, it will become a plus 18. It become a plus 18, because minus 18 go over, it's a plus 18. Minus 19 plus 18, that will give me a minus 1. Okay, minus 9k squared go over, it will be a plus 9k squared. So 9k squared minus 12k plus 1. So far, okay? Can, huh? I'll leave the rest to you. Can? I believe you can solve the rest. I won't take away the joy of solving. Okay? So I'll just pause at this page for a while. Okay. Okay, here question 5b, huh? Okay. Okay, just give me a while, okay? Just pause a while, then I will very quickly. I just answer a phone message. I'm very fast, very fast. Sorry. Because people test positive, need to reply quick. Okay. Maxine, can I go on? Can, huh? Okay, thank you. Okay, so next one, okay, I've gone through all this. This one I've gone through. Okay. Question 5b. So, okay, yeah. Sorry to keep you waiting. Okay, so let me take a look. Okay. Question 5b. This is from 5b, past year paper, right? Past year paper, huh? Question 5b. Okay. So it is given that -2, -1 is a solution of this equation. Find the value of AB. Oh, this is very similar to the one that I think Tunshen just now was asking. So when Let me see. Okay, where are you? Let me look for you. Okay, okay. If okay, can help me push your camera down so if I lose you or what, you let me know. Okay. So again, same story as what I was telling some of you all just now is that when they say that -2 and -1 is a solution, right? What they're saying is they're saying that okay, these two represent actually x and y. They represent x and y. So if you, the only thing is that your a and b, right, are coded, and we need to find -2, -1 is a solution of the simultaneous equation, right? If you imagine it on the graph, right? This guy, for example, this probably this a square x plus b square y square equals to 2 could look something like that. Ax minus by equals to 4 can look something like that. And your -2, -1 is actually this. Okay, it's actually this. Let me put xy axis. This is the xy axis. Okay, it's actually here. So what does this -2, -1 represent? It represents xy coordinate. Oh, so if this is satisfying a solution to both of the equation, right? That means, right, if I put x as -2, y as -1, the equation is fulfilled, is the same. It means that I can this coordinate satisfy this, and this coordinate satisfy this. So far, okay? What does it mean by satisfy? A lot of students ask, teacher, what does it mean by satisfy? What does it mean by fulfill the equation? Okay. Fulfill means, right, if I put the point inside, right, the equation is still intact. I don't hurt anybody. Okay, example, 1, 1 is a solution of y equals to x plus 1. Because when I put x as 1, 1, 2 is a solution of y equals to x plus 1. Because if I put x as 1 and y as 2, I have 2 equals to 2. Nobody is hurt. Okay, but if I say things like 1, 2 is a solution of y equals to x plus 3, then this one cannot, I hurt somebody, because if I put 2 here, if I put x as 2, right hand side is 5, left hand side is 2, they are not equal. So 1, 2 don't lie on the line. When it lies on the line, it will fulfill the equation. It means it supports the equation. Okay, you can see 1, 2 don't support the equation. 1, 2 support the equation here. So if they say that -2, -1, right, support is a solution, it means that it supports this equation. I can substitute, okay, -2. This is my x. This is my y. I can substitute them as -2 minus 1. A square plus b square y equals to 2. This is my x, this is my y. They also support this equation. So far, okay? Clear so far, okay? Can I see my camera hang? Do I still have you? Yeah, my
Yes.
screen. Yes, okay. Thank you. My screen hangs suddenly. Okay. So from here, of course, the linear one is the more humble one. I'll take this to create my sub. So this gives me -2a plus b equals to 4. Gives me b equals to 2a minus 4. That's equation 3. Okay, and our substitute. Let me tidy up my equation 2 a bit. This is a -2a square minus b square equals to 2. Using this and this, -2a square minus b square equals to 2. So this is my b, this is my fantastic b. Okay, this is my fantastic b over here, my b. Okay. So from here, slowly, I expand. -2a square minus a minus b bracket square. A square minus 2ab. 16a plus 4 square is equals to 2. Okay. So here what am I doing is I'm just doing a minus b bracket square. I use the identity. A minus b bracket square. A square minus 2ab plus b square. Can? So far, okay, yeah, sometimes I go very fast. So do stop me if I lose my way, huh? Okay. Minus that gives me a positive 16. Minus 2 plus, that gives me a minus 4 square, which is 16, equals to 2. Okay. And combining these two, minus 2 square minus 4a square is minus 6a square plus 16a. If I bring these two over, it's a minus 2. So I get minus 18 equals to 0. Okay. Divide all by negative 2 probably. If I divide by negative 2, I get 3a squared. Divide by negative 2, I get minus 8a. Divide by negative 2, I get plus 9. So why do I divide by negative 2? It's because personally, what I love is I like to make my square positive. That's why I do that. Okay. And I think from here, you should know what to do already. Okay, huh? So from here, you can solve for a already. Would you like me to still go on?
It's okay. I went wrong at like the number 3. Instead of b equals to a minus 4, I put b equals to a plus 4. It's the sign.
Very good, very good. Yeah, I mean, so it's actually a very small mistake, but you know, like simultaneous equation or most part of mathematics is like cooking. Well, once we it's a very small thing, like we add salt we add sugar instead of salt, then the whole dish is ruined. Also, in every step when you do mathematics, always look over your shoulder. Take 2 steps forward, check 1 step back. Take 2 steps forward, check 1 step back. Because everything at the front can affect the back. Okay?
But wait, Mr. Tan, isn't it like b equals 4 plus 2a, not minus 4?
Ah, did I make a mistake?
Isn't it 2a plus 4?
All right. Oh no. Yeah. I just commit the mistake that I made. Yeah, thank you. B 2a plus 4. You're right. So 2a go over is a plus 2a.
Wait, so I was correct. Wait, then where did I go wrong?
Where do you go wrong? Let me see. Let me do it again. Sorry. 10 o'clock already. Sometimes the old people brain don't function so well. Okay, this one, let's see. Okay, so Janelle, you help me check. You see if I made any mistake. Minus 2a squared minus b squared equals to 2. This is equation 2. Okay. Equation 3, b is equals to 4 plus 2a. So let me try. Minus 2a squared minus b squared equals to 2. Minus 2a squared minus a squared plus 2ab plus b squared equals to 2. So far still okay. I think it's quite a nice number. Minus 2a squared minus 16, negative to negative, minus 16a, negative to 4, minus 4a squared, minus 2 equals to 0. So what I did is I brought the minus 2 over. Okay.
Wait, my equation number 2, it was negative 2a squared plus b squared, not minus b squared.
Wait, let me see. Oh, okay, wait. Oh, okay, it's a y square. Sorry, it's a y square. I thought it was a y. Okay, my bad. So it's a y square. So yeah, it's y square. So it should be a square minus 2 plus b square minus 1 square equals to 2, right? Y square is a y square. Okay. So it's minus 2a square plus b square equals to 2. Janelle, correct, huh?
Yeah.
Yeah, okay. So let me go to this plus b square. So this one is a plus. So this one is a plus. This one is a plus. Don't worry, life is still good. So from here, everybody is a plus. This will give me 2a square plus 16a plus 14 equals to 0. A square plus 8a plus 7. Oh, it's a nice number. A plus 7, a plus 1 equals to 0. A equals to negative 1 or a equals to negative 7. So if I substitute, b is equals to 4 minus 2, 2. This one, B is equals to 4 minus 14 minus 10. Final answer I present, A equals to -1, B equals to 2, or A equals to -7, B is equals to -10. Remember to write the answer this way. Remember to write the answer this way, okay? Okay. Yeah, remember to, okay, when they say here A must be more than B, in the question, they say A must be more than B. Okay, so I have to reject one of them because this one is rejected. Okay, A is more than B. Okay, wait. A is more than B. Yeah, correct. A is more than B. So this one is correct. Here, how? Okay, ma? Hey, where's she?
Hi. Yeah.
Okay.
Okay. Great. Awesome.
Okay. So with that, I finished all the questions. I will try to record. I'll try to download after this.